Good morning, and thanks for joining today's webinar on RCI's migration from Oracle Coherence to Redis, helping them reduce complexity and build better applications faster. Our presenters today are Balayaj Mariappan, Senior Manager of Solutions Engineering from RCI, and Priya Balakrishnan, Senior Director of Product Marketing from Redis Labs. Balaji has 18 years of IT experience in various domains like hospitality, finance, and supply chain. He has extensive experience in managing and delivering multi-million-dollar projects with managing risk and event probability analysis. He is passionate about open source technology, web architecture, and is also quite the artist. Priya brings more than 18 years of enterprise technology experience to her role as Senior Director of Product Marketing at Redis Labs. She joins us most recently from Splunk, where she spent over 6 years heading the Splunk product marketing for IT operations. Today's webinar is being recorded, and all attendees are in listen-only mode. During the webinar, we will be taking questions during the Q&A session. You can post your questions using the question and answer module in the communication panel. Following today's webinar, an email with a link to the recording will be sent to you for future viewing and to share with your colleagues. With that introduction, Priya, the floor is yours.
Thank you very much, Jean, and thank you folks for joining us this morning in our webinar. We've divided this webinar into two sections. The first section, I will go through it pretty quickly to introduce you to what Redis and Redis Enterprise is. And at that point in time, I will essentially hand the control over to Balaji from RCI, who will go over the reasons for why they decided to migrate from Coherence to Redis and the architecture and migration process. And we're hoping we will have enough time because he does have a demo prepared as well, so it will be pretty awesome to do that. So with that, I'm going to deep dive right into why our customers love Redis. And, Redis was actually voted as the most loved database by over 100,000 developers by a survey that Stack Overflow conducted. And the reason for that is that, we're well known for our performance, simplicity, and extensibility. So let me just elaborate a little bit on what I mean about that. So when we talk about performance, so if you look at this chart on the left, in this benchmark, we actually recorded a high volume of writes, basically polling applications, and we measured what the end-to-end latency would be. And as the chart indicates, Redis essentially outperformed all the other databases with the likes of like Couchbase, Cassandra, and DataStax, where we were able to deliver almost 8 times the throughput with 1/4 the latency. And in this chart on the right, what you're essentially seeing are articles that were published on Google blog by these various vendors. And this benchmark basically compares these other solutions on what it would take to deliver 1 million writes per second. And if you see the chart here, Redis can essentially get you to those 1 million writes per second with the fewest resources at 2 server instances when compared to the likes of Cassandra, which essentially requires over 300 server instances. So what these charts essentially indicate is that Redis can give you the sub-millisecond performance that it's very well known for with the largest throughput and with the least amount of resources that you will need to actually deliver that. The second reason why our customers love us is also because of the versatility that the Redis data structures bring. We support a variety of different data structures like strings, bitmaps, hashes, lists, sets, sorted sets, geospatial indexes. And what these data structures really are is that it comes with its own set of built-in commands to perform even the simplest operations and the complex operations in memory, and it makes data processing significantly faster. The reason why many of our customers really love it is because, for instance, Freshworks is an example. They use hash, lists, and sorted sets to meter the API requests coming in. Our dynamic yield basically indexes all these personalized settings on their end users and stores them in these data structures within Redis to drive these more very sophisticated personalized experiences. So the versatility with the Redis data structures is actually another huge reason why there is growing widespread adoption. The third thing why our customers love Redis is because of the extensibility we deliver with modules. So think of modules as add-ons on top of Redis that extend Redis to cover the most popular use cases. They seamlessly plug into Redis and they're processed in memory, and they deliver the data simplicity with data structures, the performance that we're well known for, to all of these custom use cases. Redis Labs has essentially, we have a variety of modules that we have published. So we have Redis Search, that is extremely popular, and that allows you to perform these very simple search queries, but also complex aggregate queries very, very easily. But because it's developed on top of Redis, it is able to deliver significantly better performance than a lot of the other search solutions. We have Redis Graph module, which essentially extends Redis as a graph database. We have the JSON module, which allows you to use it as a document store, or the ML module, which implements several machine learning models to Redis data types and others. Right? So what this really makes is that it turns Redis into a multi-model database. We also have, we power a range of solutions, so from fraud detection to e-commerce to personalization. So for example, BioCatch is a customer that delivers biometrics based for detection. So it's a very powerful solution where they're able to identify your keystrokes and basically identify whether it's fraudulent activity or whether it's a real person actually trying to use it, and so on. And they use Redis Enterprise to power the solution. Innovonics is an example. They use Redis at their IoT edge devices to collect this data from their millions of sensors to provide real-time analytics. Microsoft, as an example, uses Redis Enterprise to power personalized experiences for their MSN services. Home Depot uses Redis Enterprise for metering and throttling the number of requests that are coming in so that their applications can handle the load without essentially keeling over, right? And the way we deliver all of this is that Redis is actually used across a variety of use cases. So Redis is very, very well known for cache. Everyone knows this is a caching solution, so there's little marketing that needs to be done there. But if you look at it, we are actually, some of the other use cases that we're very well known for are around high-speed transactions, around user session store, around fast data ingest, real-time analytics that we were just talking about, or geospatial indexing. So, Redis actually can be used across a variety of different use cases, and can also be used for, transactional, analytical, and operational use cases. So, for instance, from a transactional perspective, so let's say you want to, authenticate credentials, right? And you need to be if that need to be stored from page to page, right? Or if you need messaging needs to be published across a wide variety of consumers or subscribers to maintain data state and consistency, then we have the pub/sub capabilities. Or for real-time analytics, we have like page ranking or leaderboards, if you want to use it from a gaming use case perspective, right, where you want to maintain leaderboards, or you want to basically maintain a count of the number of users coming in, or for time series analysis. And operationally, as an example, one of the largest financial and credit card companies, they had this whole bunch of credit card transaction data that they need to be processed, and they want to use it for what-if analysis. And a person analyzing it, really needs to be able to, respond very quickly for these what-if analysis. So they essentially put Redis in between their database and their user to drive these kinds of analytics and provide these real-time results for various use cases. So where does Redis Enterprise fit into all of this, right? So if you want to go beyond a single instance and you want to automate a lot of the operations, you want to use Redis in a multi-tenant mode, and you want other capabilities around like active-active and so on, think of Redis Enterprise as this wrapper that combines the Redis instances and creates this pool of memory, right? So we have the zero latency proxy, which allows you to direct all your requests to one endpoint, even though you can have multiple instances of Redis running within a single node. And the zero latency proxy is what helps you distribute the requests. We take care of all of the scaling and automatic sharding, We have a cluster manager to manage the pool of Redis resources. The REST API can be used for management and monitoring of the Redis enterprise instances. So it really, truly makes Redis open source kind of enterprise grade, right? And you can use it for simplicity and scalability, for high availability, for other use cases also that I will just talk about very, very quickly. In addition to that, we also adopt a shared nothing symmetric architecture and make sure that the data path really faces no obstruction despite all of these cluster management features that we're adding to Redis open source. So Redis Enterprise has all of these cluster management features, but you will see no impact to the data path or the performance itself. We also have, cluster watchdogs and node watchdogs that essentially help you keep track of the health of the cluster or the node. So it helps you keep track of the throughput, the latency. It moves the Redis instances in question to manage load very dynamically. You can reshard and transparently transfer control. And this means you essentially have more instances at your disposal. You're optimizing the way you're using your infrastructure, but at the same time, you're lowering latency and you can handle extremely high throughput with Redis Enterprise. In addition to that, what Redis Enterprise also brings to the table, two capabilities that I just want to call out are around active-active capabilities. So we introduced active-active sometime late last year, and it is actually implemented by CRDT, that is conflict-free replicated data types. What that allows you to bring is that it allows you to, Redis Enterprise automatically takes care of a lot of the conflict resolution, freeing up the developers from actually having to write code to do that conflict resolution. What this delivers is with active-active based, active-active on Redis Enterprise based on CRDT, essentially allows you to, it assures local latency on read and write operations, regardless of the number of geo-replicated instances or regions and the distance between each other. So it allows you to, every individual Redis instance across these distributed data centers to operate as if it's its own local instance. So we deliver sub-millisecond latency. It enables seamless conflict resolution for even the most, for simple as well as very complex data types, like those of Redis core and Redis open source. And even for if the majority of the geo-replicated regions in CRDB are down, the remaining geo-replicated regions are actually uninterrupted. So they can continue to handle the read and write operations very easily. The second thing that I want to call out is Flash. Redis Flash allows you to, extend Redis to a combination of RAM and Flash. So what we do with Redis Enterprise is that Redis Enterprise automatically stores all of the hot data in RAM and moves the warm and cold data into Flash devices, thereby, reducing the amount of RAM that is actually consumed by Redis because RAM can get prohibitively expensive. We have a lot of customers. 6 of the top Fortune 10 companies use Redis Enterprise. We have 3 of the top 5 communications companies, the largest of credit card issuers, as well as the healthcare companies using Redis Enterprise. And we have a whole bunch of customer experiences, like White Pages is an example. They tried using Amazon Elasticache, which is single instance Redis open source, delivered as a service by Amazon. And that just didn't provide them the simplicity in scale or the cost savings that they were looking for. And so they adopted Redis Flash and were able to get the performance of Redis, but save over 70% in Amazon infrastructure costs. Malwarebytes is an example. They are able to process millions of malware data using Redis. They collect this malware information from around the globe and create these maps that they call as zombie apocalypse maps, which essentially provide you these real-time perspective of all of the malware that's happening around the globe. We talked about Microsoft eHarmony, basically uses for their entire microservices architecture to support over 1 million user communications on a daily basis. So we have a bunch of amazing customer experiences and customers that actually use Redis for Redis Enterprise for a variety of use cases. With that, I'm going to essentially hand the control over to Balaji, who will talk about why and how RCI decided to migrate from Oracle Coherence to Redis. Balaji, the floor is all yours.
Thanks, Priya. Can you hear me okay?
Yes.
Okay. Thank you. Thanks, everyone, and good afternoon and good morning. I'll be moving to the next slide. Myself, Balaji, I'm part of the solutions engineering team, and share my experience and how we managed to migrate to Redis from Coherence, where the technology was adapted a long time ago. So RCI.com is the leader in the vacation exchange space. I gave some slides where it shows the screenshots of our application. Web applications. RCI.com is the the member-facing website, web website where users are able to log in and search for their resorts and book and go on. So the variety of technology included in this website, the variety of technologies included in this website. So right from, because we have 40 plus years of in the industry and leader in the exchange space, and around 20 plus years we have in the RC.com. The time now being almost 20 years, 18 plus years in the web space. So there are a variety of technology in our stack. So right from the mainframes to the latest one, you name it, it's even Docker and AWS and everything is stacked in. So it was added in over the period of time, and the last 3 years are the important years where adapting agility and new technology, open source is the key for our success. That's what we're moving to, all new technologies, and especially the open source. So in that, going to the next slide. Trying to move. Yep. So in that, coherence is the very important, caching is a very important technology for us to give a better user experience, right? So is it a hospitality space where we have to show up rich images and giving the better user experience in all directions, right? So that is where caching is very important, especially the web, inside the web stack. Caching is managed right now. Like, in around 2009, we adopted Oracle Coherence. That time, Oracle Coherence was one of the industry leader in that technology, and we adapted it. So this particular technology stack has been evolved for the last almost 8 years, right? So a lot of new configurations, new architecture, and scaled to more capacity, and so on and so forth. So in that, if I talk more about the technology we had in our website, there are two types of caching we have. The one is managing the user sessions, for managing the user session cache, and another one is service level cache. Service level cache, which is in the backend used for the SOA architecture. But my focus is on the web session cache, and I'll show you why what is coherence and how we migrated and why we migrated it. Next slide. Yep. So this is just a quick of the meat of what I'm going to present, especially the why part. So the cost, licensing, and complexity, and performance, and monitoring, and agility. Those are the key reasons why we were migrating to Redis. So, and let's move on to the next one. So what is this? Maybe, I don't know, some of you in this call may definitely know what is coherence is, but others, it is a coherence also. Yeah, it's a cache grid, right? So, and it is so we adapted in 2009, so this is there for a while. So you see that this is the architecture what we have now, and part of them are migrated to Redis, and this is, so it is this infrastructure is built for scalability, availability, and durability, right? So if you see that right side of the diagram where the cache grids are, where it will be used to store the cache objects, right? So the web session cache also in this particular architecture only. So whenever we needed more capacity, the cache nodes will be increased. So and if you see that proxies, there are proxy nodes also in the middle, which is basically direct the calls from the clients to the cache nodes. So and you see multiple nodes in the cache where it is used for the scale for the availability of the proxies as well as the availability of the nodes. So and it's all so in the past it was the web clients were directly attached to the proxy, and in the recent like some time ago we we moved to the load proxy load balancing through F5. So this is the space it is in. So whenever there is a change required, it has to go in all the places: load balancer, proxy, and cache node. So that is, it's a cluster-based architecture, and it is a grid. And again, it is a Java-based application. So as you know, maintaining the Java application has its own challenges. I'll talk more about that. Then the next slide, please. Then this is a very famous architecture diagram. You can see it for the coherence. So here you can see the boxes of the JVM and application. So the coherence is built in a concept of L1, L2 cache. In CPU, you see that. So the closer the cache is to the application, the faster the cache objects will be received, like that, right? So in if you see that why it is the near cache, local cache, and different type of caches are there, why it is needed, right? In the past, if you see that our networking speed is less and the hardware speed is less, those are the consideration. I think this coherence is built based on that one. So that there's a near cache, which is basically baked part of the application JVM, and you know how it manages, right? So when the cache objects are part of the JVM, that needs to be managed. It requires to, we need to consider it of how the full GC will be impacted by that, and so on and so forth. And there is another cache, the local cache, which is part of the cache, part of the grid. So basically, the idea is when the user hit the same JVM, application JVM, he can retrieve it quickly. So another one is the remote cache, which is as part of the grid. So in case the if the client is landing on a different machine, so he can access that cache objects through the remote or distributed cache. And also a replicated cache, which is a backup, or you can say it is, again, you can manage at the application level, at the cache service level. You can increase the number of backups, whether one or two. So again, it is all at the configuration. I mean, the configurator, the administrators, or the whoever is architecting need to know how it should be backed up and how many backup we need, and all these things to be handled at the configuration level. So as you see, there are so many configurations available to do this, the basic setup. Okay, going to the next slide, I will show you what other configurations are available as well. Next slide. I think it's turning to the right. Yep. So the cache buckets, this is all cache scheme, you can say. So in Coherence, every cache objects can be configured at the server level itself. Like let's say, so I need a cache which needs to be there for only 2 hours, and then another cache which needs to be there for 1 hour, and one is for 1 day, 2 day, whatever. The scheme, the bucket will be created, and the developer should know where this cache object has to go, right? So it is, again, when you think about right now, the agile teams are moving around, and they should exactly know where this cache should go. So whether it has to go to the 1 hour cache, 2 hour cache. So let's say somebody is pointing to a different cache scheme, then maybe your cache hit and miss ratio will be depend on that one, right? So this is another thing, you have to know before a developer and administrator, everybody should know that combinedly know that to where to put it to make that optimum in an optimum use. Okay, so with that, I will say uh, so. Okay, next slide. Okay, so as it choices in the Higgs law, right? There is a the Higgs law says more choices, more complex. That is the curve shows that. So when the user see more options, then more choices, which is basically built for the different tech patterns. Like you have slow network, you have slow hardware, and all these things. But in the current world, you have 10 gig networks, InfiniBands, and whatever. Your network is not at all a concern nowadays. It's like people are doing site-to-site replication and all these things. So network is so fast, and hardware is it's lightning fast. So it is those are not needed. So it is very looking for a very simplicity option, right? So the complexity at her in this one is the JVM configuration you need to consider because Java Coherence is a JVM based. So you need to know how the JVM needs to be optimized, configured to make a proper full GCs or whatnot. So all these things are there, and also because of the complexity, and it is the automation is difficult, and the clustering also requires more. I mean, basically, it is a more learning time is there in this technology. That is, again, it is all our experience and sharing it with you. Okay, next slide, please. Okay, and another important thing, right, which is really mindful of many people, I think, the license. Again, the Coherence is an off-the-shelf product. It's not open source, so it comes with its own difficulties. Some people take it as advantage, and it's all difficulties. One is, if you see the sample here on-premise, on 2017, sometime Oracle changed its license pattern for Coherent, sorry, for our on-prem and the public cloud like AWS or Azure or Google Cloud. Right? If you have two CPU in on-premise, you need only one license, and if you are migrating the same two CPU requires two licenses, which is in a broader capacity, it is, or in a bigger capacity, it really matters because let's say you have 50 licenses. If you're going to cloud, you may need 100 licenses, which is difficult for some companies, some may not. So in my experience, it was one of the challenges we faced. And again, other factors which came into our consideration: managing the cache eviction policies, and the testing and monitoring, and definitely the simplicity and the acquiring of simplicity is one of the important yardstick we took to move to a new technology, and also the monitoring. So monitoring is very limited or it is we need to be stick to the Oracle monitoring tools. The open source tools are very less, but I think Redis has more options in this space. Next, please. So, uh, we went to the very simple Redis architecture. It's an active passive mode and with a load balancer. And again, this can be you can tune it. You can avoid load balancer as well. Sentinel can do that load balancing itself. You can directly connect with the web client with your library. Either it is a session managing library. You can specify which is master and slave nodes. That can also be node. But we tested with this configuration, having a load HA proxy in between and a load balancer. The HA proxy manages which one is the master, which one is slave. Based on that, the connection will go. So it's a very simple configuration, and also um, in the future, what is our plan to do that is uh, moving to this architecture, which is just trying to move.
Balaji?
Yeah, can you move to move? I can't. Can you see my screen?
Okay.
Yeah. So, sorry about that. Okay, so in the future, how we wanna do that? Either it is your choice, because Redis has an option to do active passive or cluster based. So we choose to go for a active passive mode. So based on the functionality, we wanted to build the multiple active passive nodes. So actually, there is 2 nodes, or if you want more availability, you can have a third node to make the quorum to happen. So this is our architecture for Redis. So, and from the configuration standpoint, I'll go through some of the high level configuration to understand how we did that. Okay, so the next slide. Okay, Redis is very simple. I would say, when I first time tested, it took me like half a day to learn, even try the Sentinel configuration, not more than like 4 or 5 hours to try that all the configuration. So this is a Redis.conf. There are a lot of other configurations are there in the file, but I'm just highlighting one which is really important, right? So one is it says to bind to the particular address, and you specify the port where Redis is running, and you have to say which one is master and which one is slave. Then you can specify the eviction policy, that is a ultimate, what happens if the whole the cluster, the whole Redis cache node is full. So you use LRU, which is least recently used, will be kicked off, and that kind of policy. So that is a one configuration. Then that is for the Redis.conf file you needed. And go to the next slide. Okay, so this is, by the way, we use Redisson as to manage the client connectivity. Redisson library used it, and you can. There are some people some people use Redis also. Redis, actually, when we tried a POC, the Redis was not available for Tomcat 8. So we use the Jettison, which is, again, the Jettison also, it's a very simple configuration. It goes with, you have to specify your Redis nodes with the port number. When you have a master and slave, you can specify those. And also a codec, you have to specify with the fast codec which you use, which is actually, we still want to test it. It is documented as 10 times faster than the regular codec, so which is an important thing. And also to store the cache, we use the hash map, which also the configuration are part of the JSON file. Okay, next slide, please. Okay, let's go. Okay, cool. So then the server.xml, that's where you can actually, the Redisson file configuration, either go to server.xml or to your context.xml, or and plus your catalina.sh in Tomcat. So you have to have that the JSON, the Redisson configuration, where you specify what are your Redis nodes. You have to specify there, and that will which will be redirected either through server.xml or context.xml. So, and another thing is, this is so the eviction policy is important, right? So you have a master eviction policy which comes to the Redis configuration, which is you specify whether LRU or based on, there are multiple expiration policy you can set. In addition to that, in the application, you can specify this is a Spring configuration. It came handy that you specify what cache and what is the expiry time you can specify here. This is another configuration. So you can manage each of your cache and specify what is the expiry time. So that's one configuration we use. So it's actually between 4 files you will be done with the configuration, and you will be up and running. That's what I felt. And and also felt it's lightweight. The Redis is lightweight and not many configuration required, and not a lot of learning time. That is very important, and faster. That's where it is. It makes more sense for us to migrate it to Redis. Okay. I think I'm going to the next slide. Okay, so I'm just gonna show you like how and very importantly what I felt, right, the monitoring, right? The monitoring is the one of the very key part of our am I sharing? Can you see my screen?
Not yet, Balaji. I think we're going to have to give you access.
Okay.
I think
Go ahead.
you should have control now.
Okay. Yes, I see. Okay. So can you see my screen now?
Yes, we can. We're seeing the browser right now with RCI.
Cool. Cool. So I'm showing the demo here, and you will be accessing the cache. Let's see what is this JSON ID. So JSON ID is. So you have it here. Okay. So let me go to the node. Let's see. Yep. Here you go. You have the JSON. Here it is. Your key is here, which is similar to this guy. 47. Yep, this is the guy. So very clean, easy to monitor that. Your key is here, and I'm seeing let's get all because it's a hash. Get all. Here is your object. Here is your the session object. You can see it here. So then, and the type of the key is that is a hash. And this particular piece, if you want to achieve that in actually there is a I'm logging in. So let me see that. So this is one of the key thing which I really appreciated, that it can show all this stuff into what's going on right now, and it is very easy, very important for any administrator to manage and manage and troubleshoot. And it's very easy for us to understand what's going on and what object going on. So basically, when the session happens, right, the session will be will be adding more components to it. So right now I see that I logged in, and if you see session, so the node J session is okay. It's going to say 47. This is my guy. And keys, yeah, that guy is here. So you see that, and let's get all. There you go. So this will be at every click, you will see the objects will be added to that modified in the session. So it's very clean and simple. Again, it was very difficult for us to just set it up the Coquel in the coherence world, and it gets, and again, it's very, if you are using any monitoring tool like New Relic or App Dynamics, there are open plugins where it can be managed. It can show, you can plug it in the Redis CLI, which will be uploaded to the monitoring tool and easy to monitor as well. I think that's all I have. Zone, obviously there is a lesson learned. It's can you go back to that? Yeah. Okay, so as I mentioned, so I think it is I spoke a lot in the 20-25 minutes. So mainly, it's the first thing which I would say is learning is very easy, and simplicity is the key for us. And we still need to see how this performance. And I've seen many metrics that Redis is excelling. And so originally, before we choose Redis, we were looked into Memcache and MongoDB as an option, but comparatively Redis has a more friendly and performance-wise also is better. And there is no JVM tuning required because it's not a Java and it manages on its own. That's a big plus. And cache types, and there is no licensing. Licensing is if in case if you're going for a support, the cost would be definitely comparatively less. That's an advantage. So you can scale. You can shrink your environment, scale your environment without much worries. That's what that's my experiences. And cache type also, there is not many cache types required. You believe in your network is faster, and you just go your grid and get it done. I don't think it is very difficult, and monitoring also big plus to this tool and in our stack. I think that's all I have, Priya. You can take it on.
Thank you very much, Balaji.
At this time, we're going to the Q&A section of our program. As a reminder, please enter your questions in the question section on the GoToWebinar control panel. And the first question that we have is for you, Balaji. Can you describe some of the performance benefits in using Redis compared to Coherence?
As I mentioned earlier, so we removed a lot of complexity thing, which is and it is lightweight. When we felt that all the sessions received much faster. I don't have a metric right now, but the key which is requested in the cache pool is actually is much quicker compared to my existing environment, because I had to my clusters and all these things. It's a very simple architecture. We have the only one node to hit and get it back, so it's much faster compared to my current environment. And but with the later testing, with the more metrics, I can get it.
Great, thank you. We have a couple more questions for you, Balaji. The next one is, how do you see Redis differ from Oracle Coherence regarding how you use it or expect to use it?
So in the future, they have a room to expand, scale it in many nodes, and let's say even at that current setup, we pretty much double the cache capacity, because we don't have to worry about the hardware. So more cache capacity and number of CPU we can increase as much as we need, right? So that's the first thing. And in the future use, we're planning to expand it to the other use cases as well, which are currently restricted because of the capacity requirements. So that gives us more freedom for my developers to add more cache and design the application more friendlier and for the good user experience.
Great. And the next question is around the operational benefits you have seen in migrating to Redis. Can you describe what those are?
So, so the first is manageability. So not a lot of administrative overhead because the architecture is very simple, straightforward. Going to have a active passive mode, and licensing should be another important factor. So we don't have to worry too much on when we move to a cloud architecture on counting the licenses and all. That's definitely a big overhead when it comes to operation. And monitoring, right? That's the key to any administrator think of. So when somebody is saying, okay, this session is not showing up, I can directly log into the node and see what session ID it is. I can sync with my browser and the monitor available in the Redis, so which is much easier. So definitely the big plus in the operation mode.
Great, thank you. And then there's a question for Priya. Is ActiveActive only available on Redis Enterprise? And what are some of the use cases your customers are using for ActiveActive?
Thanks, Jean. Yes, that is right. ActiveActive is only available on Redis Enterprise, so that is a significant differentiator in terms of capabilities that we offer with Redis Enterprise. Like I mentioned, ActiveActive essentially, it is built on CRDT, right? So it really delivers a different way in which you can, maintain state of data, right? So one, we assure local latency even on distributed data sets. It has its own built-in conflict resolution. We offer tunable consistency, which basically means that we're guaranteeing that all the updates will be observed eventually, but at the same time, we're ensuring that you will eventually come to a converged state when it comes to data state. Because we're using CRDT, we really simplify application development. So all of the conflict resolution is actually taken care of by the database itself, and the developers don't have to manage all of these, tedious tasks around like resolving the conflicts in the application layer. So what are we used for? For instance, we do see a lot of our customers using it from user session migration across data centers. So if you want to optimize user experience, as an example, Groupon, uses it to make sure that your user experience goes, as you go from one data center to another, then, your experience or anything you've added in terms of coupons are seamlessly transferred across these data centers. So session migration across data centers is actually a common use case. There's a question in the Q&A section I was just noticing around like DR and backup and high availability, but one of the things that our customers also use this for is around node failures and handling it without any data loss, right? If you want data consolidation, that's another use case that our customers are using ActiveActive for. Distribution of load, the ability to distribute load across multiple servers is very critical when you're having like high volumes of traffic or data streaming operations. So we see customers using for that as well. And of course, if you have geo-distributed app functionality. So for example, if you have social media apps, or you want to track counters or track engagements, such as likes or shares or retweets or so on, then such a functionality actually, or if you want to track bids for stocks, right? Things like that, then ActiveActive is actually very powerful as well.
Great, thank you, Priya. The next one's also for you. What is the difference between open source Redis and enterprise Redis from Redis Labs?
Awesome. So that's actually a great question because it allows us to also talk about, some of the capabilities you get in addition to what Redis open source is already well known for, right? So in Redis Enterprise 5.0, we introduced something called the Redis Cluster API, and that along with the shared nothing architecture that Redis Enterprise brings to the table, it actually delivers exceptional linear scaling. So, we recently have a blog that we've also published on that where we are able to, deliver, extreme linear scaling on extremely large volumes of throughput without any compromise to performance at sub-millisecond latency. So our latest benchmark, as an example, is that we can deliver, so the previous benchmark was that we could deliver 10 million operations per second on 6 EC2 nodes at sub-millisecond latency. Then we published another benchmark around 30 million operations per second with 18 EC2 nodes still delivering sub-millisecond latency. And now the latest benchmark is our ability to deliver 50 million operations per second with just 26 EC2 nodes at sub-millisecond latency. So we're actually delivering super linear scale. So even though you're adding a lot of the cluster operations, that does not compromise performance, and we're able to deliver it with the least amount of resources available. We talked a lot about like ActiveActive, so I don't want to talk about that again. That's again another feature that's available only on Redis Enterprise. Then we also offer, a lot of high availability capabilities. So because we have our own node watchdogs as well as cluster watchdogs, we offer automated zero downtime scaling, right? We provide uninterrupted high availability. And oftentimes with Redis open source, you probably need something like Sentinel or so on. But then with Redis Enterprise, we have our own built-in, so-and-so monitoring and failover capabilities, which allows you to failover within single-digit seconds, right? We also offer durability options, so persistence options around, AOS per write, or we have snapshotting, right? So this actually makes it very ideal for cloud deployments when you want to persist to, say, a network-attached storage, or want to guard against any ephemeral storage layer, right? So then, built-in persistence actually is very, very powerful. We talked a little bit about Redis on Flash. Redis on Flash allows you to really extend your RAM onto Flash SSD. So we have a lot of customers like White Pages and Dynamic Yield and Innovonics and a whole bunch of others that have actually used Redis on Flash to gain significant cost savings in their infrastructure costs as well. There are a whole bunch of things that I can go through, but these are some of our top highlights.
Great. Thanks, Priya. That's very extensive. And then one more question for you. What are some of the reasons you should choose Redis over Pivotal Gemfire or Hazelcast IMDGs?
IMDGs. Okay. So, in-memory data grids are actually very powerful. I mean, right now they're kind of emerging or as in-memory computing platforms, right? And initially, when they were first introduced many, many years back, they were kind of referred to as distributed caching platforms, but then they've kind of emerged and become this, they provide a lot of similar capabilities without a doubt. But at the same time, what you have to understand is that with IMDGs, I mean, they've become these really big applications, or big applications which allow you to do these extremely complex use cases well. So if you want a super complex workload, then you probably need something like a data grid, right? But at the same time, if you want something just for simple cache, then it becomes too much of an overweight solution, right? You don't want all of the capabilities around that. So what I think Redis really allows you to do is it allows you to really use this for all of the use cases. Like if you want very basic simple caching use cases, sure, go to adopt like Gemfire or something. If you want complex stuff with like super complex data grid-like operations, then Hazelcast or something would really fit well. All the other use cases that we've spoken about today were actually an extremely good fit. And in terms of performance and with this at the scale, I think that we are the only ones that can deliver it in with such consistently, right? So I hope that helps a little bit. And if you want, I don't know if, Balaji, you want to add anything to that in terms of your experience with Oracle in addition to what you've already said?
I think you covered pretty much everything, Priya. Again, I think I insisted many more times on what our experience and why we turn into Redis, right? So the majority of the time that the manageability and the simplicity were the reason why we are moving towards this. Yeah.
Got it. Perfect. Thank you.
Well, that's all the time we have for questions today. So I want to thank you, Balaji and Priya. And before we conclude, I'd like to invite you to another webinar next month with Darren Chinen, the Senior Director for Data Analytics and Artificial Intelligence at Malwarebytes, which will be discussing his use of Redis Enterprise to collect millions of malware data from across the world to power real-time visualizations on global threats, attack vectors, and malware. The registration link to this webinar is now open on our website. And on behalf of the entire Redis Labs team, thank you for joining us today. We are at an end of another webinar. An email with the link to the recording will be sent to you for future viewing and to share with your colleagues. Join us next time by going to redislabs.com/webinars and check out what's on top and register. Until next time, thank you all again for joining.